people continue to trickle in. If you don't know who I am, my name is Elizabeth Smith. I completed my PhD here at the University of Oklahoma in December of 2018. After that, I spent a year working as a postdoc at SIMS, and now I am a research meteorologist at the National Severe Storms Laboratory. And throughout all of that time, I've been focused on the boundary layer, ranging from the nocturnal boundary layer to now severe storm boundary layers. But the common thread through all of that for me, myself, is observations, but I've also worked with models. So I'm going to share a little bit of that background today, talking about a new initiative that I really hope to get buy-in from this community to support it going forward. So the name of this talk is the same as the name of a white paper that you might have already seen. If you haven't, I'll be showing you pretty soon. But this is pushing the boundary layer. And what we're trying to do here is put together an initiative in our community to work together on boundary layer research as it becomes more relevant in interdisciplinary spaces. Before I get started, I want to mention that I didn't put this together alone. Tyler Bell of SIMS and also SOM helped a lot, as did Dr. Jeremy Gibbs, who is also a research meteorologist at NSSL. So together, the three of us are kind of the ideas behind this. So I want to give them full credit as well. So why do we even care about the boundary layer, right? Well, the boundary layer is the lowest layer of our atmosphere. It's the portion that's in contact with the Earth's surface. This is the part of the atmosphere in which we live every day, the air we breathe, the part of the atmosphere that we impact. And conditions in the boundary layer don't only impact weather, they also impact the human condition through heat waves, air quality, and more. So another reason to care about the boundary layer is renewable energy. As we move forward as a society, renewable energy options are becoming more and more in demand. Here in Oklahoma, if you drive up I-35 very often, you've probably noticed that more and more of these turbines have been going up, seems almost monthly. So it's definitely a big focus here locally. Another big operation we have here in Oklahoma is agriculture, of course. And as our climate changes, it becomes more and more important for us to understand the conditions near the land surface and the boundary layer to be able to provide for that community. So the growing needs of society make it pretty clear. We need improved observations in the boundary layer. We need improved understanding in the boundary layer, and we need improved prediction of boundary layer phenomena. I'm not the only one that thinks this, though. If you've been keeping up with some of the large-scale national reports from the National Academies of Sciences, the National Research Council, NASA, all kinds of individual publications, this is a theme that's been brought up a lot. And most of these reports commonly state that we can partially attribute limits of our current knowledge of the phenomena that occur in the lower atmosphere to limitations in our capabilities to observe that portion of the atmosphere. And so we need to invest in and increase our ability to do that. There are different ways that that's talked about, and we'll get into some of that later today, but it seems to be a cross-institution call to really increase our abilities in this part of the atmosphere. So here's a quick little example of what that might look like. This is where we are now. Please do note this is not to scale, but this is an example of what conventional observations that are deployed today might look like in a daytime cloud-topped boundary layer. So we have satellites, right? They're looking down on us from space, but oftentimes the types of satellite measurements that we would need to understand parts of the boundary layer, like temperature, moisture, they lose resolution as they approach the Earth's surface. So higher resolution closer to the satellite, lower resolution deeper in the atmosphere they go. Also, with the presence of clouds, clouds can completely obscure the ability of the satellite to see the boundary layer at all. So some big challenges there. We also have aircraft, which you can see kind of exiting the cloud layer in this little cartoon. And those aircraft oftentimes are equipped with temperature sensors, sometimes moisture sensors. And as these commercial aircraft come in and out of airports, they might collect profile data during their landing and takeoff sequences. That's great. That's an added source of information. But of course, by the nature of air traffic, that's episodic and only available near these larger airports. So it's not really a solution either. Then we have some stuff deployed here on the surface. We'll have surface towers, like you can see to the left of this little stream that I've drawn in here, that can tell us a lot about the conditions of the surface. We're fortunate here in Oklahoma to have the Oklahoma Mesonet, so we have pretty mesoscale coverage of such stations, but elsewhere in the country, that's not necessarily true. We have Doppler radar. Here in the United States, we're fortunate to have a very good operational radar network that can provide us some information about boundary layer features, but due to the curvature of the Earth and the angles at which radar scan, oftentimes if you're not quite close to the radar, you're not measuring anything in the boundary layer anyway. Then we have balloons. Everybody likes balloons. Everybody cares about balloons. But the operational balloons that we release, these radiosonde packages, are released at 0 and 12 every day, right? And that's great. Those are really important times for us to understand, but they're not the only important times for us to understand about boundary layer evolution. And of course, as the balloon flies, it only traverses the boundary layer for a portion of its flight. So that's also not really a solution to getting information about what's going on in the boundary layer. So all of this together comes together to kind of demonstrate that we do have this boundary layer data gap. So this isn't a new concept. If you've been to this seminar series before, you've heard about it. If you've been to a CAST talk before, you've heard about it. But I just really wanted to illustrate for you what this data gap might look like. Of course, observations aren't the only piece of the puzzle. Our numerically oriented friends are also a really key component here, and boundary layer processes are critical to those efforts. For any type of modeling that you want to do, and of course, numerical weather prediction, representing boundary layer processes are crucial in order to have faithful models across scales. So ranging from the fine scales of LES and DNS, where you need good turbulence closures, all the way up to these global, more coarse climate models where you really need to parameterize what's going on in the boundary layer. Everything in between, seasonal to subseasonal prediction, convection allowing models, all of these things need good estimates and representation of boundary layer processes. Of course, this also applies for data assimilation techniques and the crux of it all, boundary layer parameterization. And that's what I want to talk about a little bit here, just as an example. So we've all heard, and we like to kind of scapegoat, I think, boundary layer parameterization sometimes for why our models aren't doing what we think they are doing. And maybe that's fair. In most cases, these boundary layer parameterizations and mesoscale models that most of us are more familiar with are operating as a 1D column. So there's not a lot of information coming in from the horizontal. And these parameterizations also are often making pretty big assumptions about the state of mixing and energy transfer in the boundary layer. So steady state conditions, which is rarely true in the real atmosphere, and horizontally homogeneous turbulence. And then the big assumption that's important here is that depending on how big your grid spacing is, you are assuming that the largest energy containing motions are smaller than your grid spacing, so that they are completely contained within your subgrid scale. So there's two big problems here. The first one is that grid spacing problem. We're seeing across the community that as computing access becomes cheaper and more accessible, these grid spacings are really starting to refine, and we're commonly seeing 3 kilometer sub to 1 kilometer, and sometimes even finer grid spacings being deployed in these sorts of frameworks. So when you get there, and that's what this plot over here from Wingard is showing, when you get there, when you get to these smaller grid spacings, you're not fully resolving the boundary layer motions, but they're also not all the way contained within your subgrid scale. And so you're in this terra incognita range. And the parameterizations that we're currently using are not equipped to deal with that at all. So that's part of the push for the development of scale-aware physics. On the other hand, the basis on which a lot of these schemes are developed, oftentimes it includes decades-old data. It's, again, assuming this steady state condition. It's really crafted for a limited regime or a limited condition. And we know now for sure that capturing these more complex effects and definitely capturing heterogeneity and evolution, or you might call it advection, is really important for representing the boundary layer well. So the bases on which our schemes are developed really might not even be relevant to the things we're applying them to. So those are some pretty big problems that we should probably start to think about. But all of that is great. Why is it relevant to us in this building? One of the really amazing parts about being part of this community is that there are so many of us here working on different projects and maybe different micro-focus areas, but we have the capability to bring them together. And outside of pandemic world, we're all sitting down the hallway from each other. And so we have a really important opportunity to try to align some of our efforts and really go from just building new basic knowledge to pushing this all the way through to societally beneficial work. And this type of work that I'm talking about, this boundary layer effort, it can really be transdisciplinary. So here at the Weather Center, our partners have been historically recognized for things like severe weather research, maybe radar meteorology, mesoscale to storm scale prediction, but our scientific landscape is evolving. And as that happens, so does the strength and focus of the partners that are in this building. And so it seems like the time is right for us to really look at how we can apply this model of collaborative efforts at the Weather Center, leverage our strengths as experts in our field, and really lead a new effort in boundary layer meteorology nationally and around the world. Boundary layer research is happening in the building. I'm not standing here pretending I'm the only one doing it. We, of course, have the CAS group developing UAS tools, which are really changing the way that we can see boundary layer phenomena. We have a newly committed team at NSSL working on boundary layer observations and also numerical efforts in the scope of boundary layer research. At the School of Meteorology, there's work going on in land-atmosphere interaction, turbulence dynamics, analytical modeling. We, of course, still have our partners developing some state-of-the-art radar applications, which can be important. But some of the unique things here that we have operational partners in the building, so we can learn firsthand how our changing understanding of the techniques, data assimilation techniques, and even porting things to operational models. So it's a really unique opportunity for us to take our maybe basic research and put it directly to the community and try to make impacts on society with what we've done. So what happened here is that we're sitting around thinking about this. When I say we, I mean myself and Tyler and Jeremy. And we had these conversations and started to think, maybe now really is the time. As I think everybody here knows, we're in a global pandemic. And so a lot of our field programs and things that usually eat up a lot of our time have been postponed. And so we've, for the first time in my short career, have had the time to really stop and think about where we are now and where we have the opportunity to go. So we put together a plan. First, we just simply gathered research on where boundary layer and boundary layer tangential science has been and where it's going. And we are fortunate that the AMS just released its 100-year monographs. There's lots of interesting stuff in there that we could really start to compile and put together. Based on that effort, we then developed a short survey, which I'll show you here in a second. And we pulled just a tiny sample of our Weather Center community for their thoughts about boundary layer science and how important it might be. We used the outcomes of that survey to design the goals and action items that I'm going to present to you today. We drafted that into a white paper, which if you haven't seen it, you can download it by holding your smartphone up to the screen right now with the camera open. It should open the link automatically, or I think Jeremy or Tyler could drop a link to the BLISS webpage where you can download the paper. With the content of the paper is a lot of what I'm going to be presenting today, but it's in much more detailed format. So definitely take a look at that if you have the time. Then we want to present those ideas to the community, which is what we're doing here today. So you guys are the community, and then hold sessions to really get feedback and establish those relationships in the community to take this from just kind of an administrative idea to actual tangential or tangible things that we're doing. So we'll be holding focus group sessions later this week. I just want to quickly note that they were very intentionally designed to ensure both a diversity of background and scientific focus, but also a diversity of career stage. So if you were not invited to that focus group, that doesn't mean that we don't value your input or you're not relevant to this. It's just we really wanted to keep them quite small given the virtual framework. But we do want your feedback, so there'll be an open community feedback session later next week, where if you're not part of the focus groups, or if you are, you can give us some more feedback as well. And that'll be held same time, same place, same Google Meet link that you're on right now, just a week from today. So after all of that is done, we want to revisit that same white paper with new input from the community and then take it to our unit directors. So all the people that are making the big decisions in the Weather Center, and really hopefully make impact on how we all move forward as a community, and then solve the world's boundary-layer problems, of course. So back to that survey that I noted, so this is kind of showing you the method that we use to put some of this together. We only asked 3 questions, and the way that the questions were exactly worded to different people we sent it to might have been tailored to what that person's focus is, but the gist of the question is here. So for question 1, we asked, what are the big outstanding questions you see in terms of boundary layer science? And we asked the respondents to split their ideas between long-term and short-term goals. Interestingly, if you really look at these word clouds, the short-term goals, we see a lot more researched operations type things, which makes some sense. We see things like born on forecast, field experiments, forecasting, just these kind of thoughts that are things we can do right now. Then in the long term, you'll see things more on process, right? So understanding the actual science behind what's going on in some of these spaces. The next question we asked is, what tools have been used or are currently being used to address these goals? Again, we asked them to split their answers into observational tools or numerical tools. I particularly find the observations one interesting. I'm biased, but we of course see radiosonde striped across that, and we all know that observationally radiosondes really have been one of the main tools that have been used to form our science. But what I thought was really encouraging about the feedback we got from the community is you also see some of these more state-of-the-art or cutting-edge tools as well. So you'll see LiDAR made a really big impact, also UAS. And so this community is really thinking about how to push the envelope on what's observationally possible, which I think is exciting. On the numeric side, I was also excited to see that it wasn't completely dominated by forecast models. Forecast models are important, research operations is important, but in order to improve those things, we really do need to learn more about processes, right? And so I was excited to see these mentions of idealized studies, OSSI frameworks, things like this. The last question we asked was more of a grand question, and this was, what tools or knowledge are we missing? What do we need to really address these outstanding questions and move the science forward? And what I really took away from the response to this is that everybody kind of made the note that this is hard. It's going to be difficult to do. And that shouldn't be a reason not to do it, because we have the experts in all of these different parts of the puzzle here together. And so if anybody is able to come to really realize this difficult task, I think it'll be us. I think we have an opportunity as a community to be the solution to this. So from all of that, we put together some relevant science goals that we think this entire community can share interest in. And we split them up on timescales. So I'll be sharing with you some short-term goals, which are goals that we think can be quote unquote accomplished or big progress made in that space within 5 years. Then we have medium-term goals, which are things that we're definitely going to start working on in the very near future, but it's going to take longer than 5 years to really make big leaps in that space. And then we have long-term goals, which will be the last ones I share with you. And those are the things that are really going to shape the future of boundary layer work in this community. Unfortunately, I can't share all those with you today. You don't want me to talk for that long. So again, please see the white paper for details. You can click the link in the chat or use this QR code on the screen to download that paper. So let's start with short-term goals. So there are a few listed here. I'm going to talk about the one in blue. But before I do, we listed nocturnal convection initiation. There are a lot of people in our community that are working on this problem right now. And if you look into the literature from people in this community and people also not in our community, but there's been a lot of progress that's happened in the last couple of years. And I think that we're getting pretty close to a new understanding of those processes associated with initiation of convection at night. And so I do think that making a concerted effort to bring those people together and work on a single path would be conducive to all of us. And I think that's something we can really do. Thermodynamic profiling improvements is in reference to the quickly increasing capacity that we have for boundary layer observations, and thus the new work that we're doing in order to turn those observations into value-added products that are useful. And the science is really moving there. The commercial environment is also moving there. And so I think there's a lot we can do in just a few years. And of course, near storm environment observations, this is a perennial topic. As long as NSSL is in the building, this will be a topic. But again, since we're really expanding both our observational capacity and our capacity for high resolution idealized modeling, we have an opportunity to learn new things about those environments and look at them in new ways that we've not been able to do before. And it's a pretty exciting time to be doing that kind of work. But the one I want to talk to you guys about today, because I think it's most applicable across the spectrum of people that should be interested in boundary layer research, is updating the parameters and empirical relationships in the boundary layer. And what I mean by that is, a lot of the basis, again, for boundary layer parameterizations are based on these empirical relationships or empirically deduced parameters that were gathered from oftentimes decades old experiments. So the picture I'm showing here on the right is actually from the Kansas experiment, where a lot of this data comes from. You'll see the year is 1965. Data being old is not a reason not to use it, but we've been able to really increase our capabilities observationally. And so this gives us new opportunities to revisit those parameters and relationships. On top of that, we have the opportunity to gather statistically relevant data sets that can inform us about the ranges of those parameters or the physical ranges that those relationships might have. And knowing what those ranges are is really important for the implementation of scale-aware physics and also for stochastic approaches to developing spread and ensembles without being multi-physics, right? So we need to know how to perturb these different relations or parameters in a physical way. What do we do though? I put this under short-term goals, so how are we going to do that? First, we really do need to build that collaboration between the people that collect observations and the people that run these models. I know that's almost a trope. It's said all the time. It's hard to do well, but we really do need to do that in order to identify priorities in which parameters we want to focus on. Then we need to conduct these long-term targeted campaigns to collect these sorts of observations in multiple regions and regimes. I know long-term campaigns is scary to a lot of people that operate instrumentation, myself included. However, with the CLAMPS platform, for example, we actually already have years of data from some locations. So the Southeast is a good example. The ARM site, of course, also has years of data. And so if we can learn something new about how we can use those data to compute some of these things, we can then go back and retroactively do it without having to recommit our systems. So there's some opportunities to be creative in how we execute here. But this can really contribute to improving numerical weather prediction and just modeling in general across scales, because they require adequate boundary layer and turbulence parameterization. And when I say boundary layer parameterization, I want to make it clear that I'm talking about the whole energy chain. So the land surface model, the surface scheme, and the boundary layer parameterization itself are all relevant in this discussion. So now into medium-term goals. Again, these are the goals that we think we'll be working on soon, but they're going to extend further into the future. Convection initiation, again, perennial topic. We're going to keep hearing about it. There's been a lot of work already done here, even decades ago now, but as I've said, it's kind of a theme. Our numerical capabilities and our observational capabilities are growing at such a rate that we can really explore these topics from a completely new perspective and hopefully learn new things. Something that I think could be a really important focus in this community is trying to understand more about the physics that contribute to boundary layer properties that are important for renewable energy resources. Wind energy is the obvious one here, but this is also relevant for solar energy. Cloud top boundary layers are still pretty difficult for us to predict well, and that's obviously important for output for solar energy capacity. So I think this is somewhere where our community is well suited to move forward, and it's also immediately impactful to society. But the one I'm going to talk to you about a little bit in detail today is robust observation technique development. So I've been harping that we've been developing or growing our capacity for observations, but that's happening really fast, and the market is moving really fast. There's a lot going on, and so what's kind of been happening is these new instruments are coming in, and so we just keep using them the way we know how, because that's all we have time to do. But I think that we would be very well served to devote time and effort and invest in that time and effort to develop complex and novel observation options with our current suite of instrumentations. So what I'm showing you here on the left is an example of that. This is from the Portugal experiment conducted a couple years ago in Portugal. And what you're seeing is scans from several lidars all in the same valley. And you see that these scans are intersecting at various points, and this allows us to build these virtual towers and do some other interesting stuff with coplanar scans. So there's a lot of opportunity that we're just not really realizing because we haven't had the time or the investment to develop those new techniques. Another aspect of this is thinking about multi-platform data streams. We talked a lot about the data gap at the beginning here, and it's not clear that there's going to be a one-size-fits-all solution. It's unlikely that uncrewed aircraft are going to be the solution across the entire United States. It's unlikely that the solution will be ground-based profilers across the entire United States. So how can we combine different data streams optimally to create better value-added products? I think that's a really important question. Something that we need in order to do this work are quality observation simulators. And when I say simulators, I do not mean creating a synthetic observation by just taking a wind profile and calling that the LiDAR observation. I actually mean predicting and evolving the fields on which the observing principle operates. So in the example of Doppler LiDAR, we would need to predict and evolve the aerosol field that act as scatterers for Doppler LiDAR. There are a lot of reasons why we should be doing this. One, we can test deployment strategies for a whole lot less cash than just going out there and trying it. But on the scientific side, I think this lets us address the reverse hypothesis test order that we're kind of starting to see as our numerical assets increase. So the example I'll mention here is the streamwise vorticity current. That's a popular topic in severe storm communities. There are these very high resolution models that have been showing this feature. And at first, what was happening is we were taking the observation platforms we have and going out there and looking for it. Whereas historically, maybe the opposite is true, right? You go out, you observe something, and then you try to update your conceptual model based on your observations, and you go in the loop in that order. With the advent of these very, very high resolution simulations that might be perhaps more physically faithful to what's going on in the atmosphere, we need to be able to create new ways of observation to confirm those. And along those lines, this can help us reduce the risk of failure to find the observed feature that we're looking for in the field. Of course, synthetic observations are still important. In this case, I'm calling those emulators. These are still really useful for conceptual models and for Aussie-style approaches. So I don't mean to dog on emulators. I just think simulators are really what we need to be developing right now. And this brings me now to long-term goals. And I actually want to talk about a couple of these. This is where we're going to spend some time. So one of the long-term goals that's listed here is improving boundary layer parameterization. And that might feel redundant based on the very first goal I talked about, which was updating these parameters and relationships. But really, I think we see it more as step one and step two. Anybody that thinks that we can just take observations and then just poof, an improved parameterization is available is not familiar with what the inside of parameterizations look like. This is going to take a lot of time and a lot of effort from different people with different expertise. Again, I think that we are uniquely suited here in this building to bring those different parts of the puzzle together. So I think that that would be an important goal that's impactful across several fields. Supercell dynamics, of course, that's always going to be important for NSSL. Another one is the role of aerosols in convection. And I want to put an asterisk on convection in this case. When I'm mentioning convection, yes, convection storm sense, but also the role of aerosols in convection in the boundary layer sense and the development of clouds associated with boundary layer convection. There's a project happening maybe this summer associated with ARM that's looking at that directly. And we do have groups here at the Weather Center that are part of that. But I think that it's going to take a much longer effort and a development of new expertise in this community to be able to make strides in that space. So the other two I'm going to go into detail about. We'll start with land-atmosphere interaction. This is kind of the forgotten thing in what I've talked about today because it's just hard. But we know that understanding land-atmosphere interaction, and really this should probably say surface atmosphere interactions because it's true also for ocean surfaces, ice surfaces, the surface of the moon, I don't know. But it's critical to many fields and many applications. So you need good representation of land-atmosphere interaction for climate simulations, for agricultural weather forecasts, for lower boundary conditions and idealized simulations, for seasonal to subseasonal prediction. I mean, all of these things are really critical. And if you look at the diagram I have on the right, which is from a paper describing the Laufey experiment, you can see how many things go into this. It's not as simple as just collecting some flux obs, right? Similar to our boundary layer parameterizations, a lot of our land surface models also are relying on decades old data that is perhaps being collected in a region that is not at all appropriate for where it's applied. And due to these perhaps missed applications, that's the only option we have right now, the errors in subsurface quantities can oftentimes be on the order of magnitude of the values themselves. And that's bad, right? I mean, that gives you almost no confidence in the value at all. So something that we need to develop in this community, the Weather Center, is research-grade observation capabilities for characterizing the subsurface and the surface itself. We have decent boundary layer observations, but in that surface layer and at the surface, maybe not so much. Another facet of land-atmosphere interactions is an opportunity for us to engage with the geocarb mission that's seated here at OU. If you're not familiar with it, one of the goals of geocarb is to monitor plant health and vegetation stress across the Americas from space, and to probe the natural sources, sinks, and exchange processes that control various constituents in the atmosphere. Of course, that's going to require space-based retrieval of fluxes of these constituents, and unable to do that well, we need improved understanding of boundary layer processes and how to collect boundary layer profiles to constrain such retrievals. Of course, across the board, improved understanding, modeling, observation of the boundary layer can all contribute to the geocarb mission. And I think that this just gives us an opportunity to bring in another level of collaboration. So this is the big one, in my opinion. This is my opinion. I don't want to speak for Tyler and Jeremy, but I think they agree with me. Training and recruitment. If you've been watching the job boards at all, you may have noticed that some of those listings that have been going out and then staying out and then maybe disappearing and getting relisted have been in spaces of boundary layer science. It's been boundary layer observations, maybe boundary layer data assimilation, boundary layer model verification. There seems to be a shortage in the broader atmospheric science community of students or researchers entering the field that are both well-trained and interested in boundary layer science, and that's a problem. I think that there are some different ways we can look at the candidate pool, but I think before we do that, we have to think about what we really need. The big thing that we need is content experts, of course. That's what everybody always wants for anything. You want people that really understand the field that you're trying to make change in. I think in our case, what that looks like is people that understand and work with boundary layer theory and concepts. Okay, so they're really working in boundary layer science. And they know or are willing to get that in-depth kind of on-the-job training about the state of the art in novel observation methods and numerical methods, because I think those three things together, kind of the trifecta that can allow leadership in this space. And we need more than one of them. One person can't carry this. We need to build a community of these content experts. In addition to that, we need observations people and modeling people that have interests in each other, right? So I would classify myself mostly as an observations person. I appreciate the modeling community. I have some knowledge in that space. I know I'm not an expert, but I feel that I'm at least partially informed such that I can start to consider how my work can be important to that community. In the inverse, we need people in the modeling community that are really thinking about observations and what is possible with observations and how we can advance the way that we run our models by collecting new observations instead of just taking the observations of the package and applying them as validation or assimilation or whatever. But all of that is moot if we don't have a candidate pool. So how do we grow this candidate pool? I think there are a couple strategic steps we can take as a community. One of those is collaborations. And when I say collaborations, I mean collaborations within this building and also collaborations with people outside. The collaborations with people outside of this building can really help us build pipelines of experts from other institutions to come into our community. So that would be students or early career scientists, even mid-career scientists, who knows. But I think that's a really important step that we could be taking. Student mentoring. I think that it's very important for those of us that have the opportunity to work with students to really spend the time, sorry, my dog's barking, to really spend the time training young students and exposing young students to boundary layer concepts. It seems that when you look at the community at large, there's been some shift toward education in more applied concepts. And that's fine, that makes sense. The job market is changing and applied concepts are really important for modern students, but there are students out there who are still really interested in the nitty-gritty technical stuff. And at least locally here, it looks like the first nitty-gritty technical thing that those students are getting exposed to is data assimilation. And so that's where those students gravitate. But there are opportunities in boundary layer to do that sort of work as well. And we really don't see undergraduate students coming out of their degree programs knowing that that's true. And so we have work to do as this community to expose those students to these ideas. We also can work on our visibility in the broader community. And so that includes publications and presentations at conferences and symposia, of course. Big bonus points in this category for the collaborations within the Weather Center. And the reason I say that is that, as I've been harping on for the past 20 minutes, one of the really beautiful things about being here in Norman is being in the Weather Center or virtually in the Weather Center and having access to each other and having access to these ready-made collaborations. And so we need to capitalize on those for our own gain, but also in order to market that collaborative concept to people that might be considering what a community like ours has to offer to them. Another aspect, I think, and I'll come back to this toward the end, is the summer school concept. So I participated in summer schools before. It's a week where you have some experts in different parts of the field presenting, and then you have maybe some newer scientists or students there together, and you spend half the week in lecture and half the week in doing a project that you aren't already an expert in. So it's a real opportunity for knowledge sharing within the community and also new expertise development. And when I say that, I mean cross-generational knowledge sharing, right? So a lot of the problems that we're approaching are problems that have already been covered, but we now are looking at them in a new way. It's important to retain that original knowledge and not waste our time recreating the wheel, so to speak. So intergenerational knowledge transfer and also transdisciplinary knowledge transfer. I know that there's a lot that I could learn from my colleagues that are working more in land atmosphere exchange. It's somewhere where I have a lot to learn. And I think that I can help, for example, more storm dynamics interest people by providing my knowledge about boundary layer processes. So this transdisciplinary exchange is also very, very important. The last one I want to talk about today is the brand of boundary layer science. If you've been to a boundary layer conference or maybe a boundary layer oriented session at something like AMS, you might know that their talks in those sessions have a tendency to get a little heavy and a little dry. And I don't think we're doing ourselves a good service in really advertising what boundary layer meteorology can be, how applicable it is, and how exciting it is. I love boundary layer meteorology, and it's, it's not all dry engineering flows. Engineering flows are important, but there's so much more in boundary layer science, and people don't know that. And when I say people, I mean students, but I also mean the other scientists in our community. Outreach is important. Science communication is important. It's important, of course, to the public, but it's also important to our fellow scientists. They'll never know that we're relevant, and they'll never know that we're important if we don't do our job communicating what we do to them. And I would argue that right now we're not always doing our job well. So we have a lot of work to do there. So now that brings me to the recommended actions. These are absolutely open for feedback. This is just where we landed at the end of developing this document based on the science ideas that came up. Seemed like we needed to take a set of steps to get to those. So the first one is to continue the expansion of our observational capabilities. As I've mentioned, the commercial market is moving fast. We have to be careful to not become complacent and get left behind while new technologies are being developed and applied elsewhere. We need to invest in the people and their efforts to innovate new observation concepts instead of continuing to do the same thing with just slightly newer instruments. We also need to continue to expand the position that we have at the Weather Center as community leaders in this area. When people think about the Weather Center, they think about, for better or for worse, storm chasers. They think about Twister. They think about those sorts of things. We have clout in that space, and we need to make sure that we continue to carry that appropriately and expand on it when possible. We need to support existing and initiate new collaborations. As I mentioned before, that includes internal collaborations and external collaborations. This is important not only for science, it's also important for funding. We have to find ways to be interdisciplinary and intra-agency friendly, and find ways to cost effectively find solutions for all of us. Those internal collaborations that can happen in this building should really be identified immediately. We can all move forward a lot faster and a lot easier if we stop sitting in quiet competition and instead really all, take steps forward together. Hiring and recruitment considerations are critical. And when I say that, I mean that hiring at all levels, including students. For example, at NSSL, thankfully, we've been supported in such ways that we can purchase new instrumentation. But that means that our number of boundary layer observing platforms are starting to outpace the number of people we have that are interested or know how to operate them and apply their data. So that's something to really consider. School of Meteorology, recent and impending retirements and career transitions have really resulted in a partial downsize of the boundary layer oriented research that's happening there. And I think in the Weather Center community at large, we've been having these conversations over the past probably 5 years or so about maintaining our strengths, so what we're known for traditionally, but also expanding the horizons of research that we can do. And I think the boundary layer focus is a really kind of Goldilocks solution to that problem, right? As our numerical and observational capacities change, a lot of what used to be considered mesoscale or even storm scale problems are now boundary layer problems. And a lot of what we need to do for climate style research has to do with understanding how our Earth and atmosphere, or the atmosphere and any surface, are in contact with one another. So I think that there's space here to do both. Spread the word. When people think about the Weather Center and they don't really think about boundary layer research, I know that when I accepted the position I have, I got some feedback of why would you stay in Norman to do boundary layer research. So need to change that attitude a little bit. There's also a lack of understanding of the true breadth of research that falls under the boundary layer umbrella and how applicable it can be. Even locally, there are scientists in this building that don't know that boundary layer research and boundary layer observations, boundary layer concepts can be relevant to the work that they're doing. Related to that, spread the data. We have more data than we know what to do with. And if we can bring more researchers in on efforts to use those data and apply those data to new problems, we can really start to expand the applications of boundary layer and boundary layer tangential concepts in research. We have to build those modeler observationalist relationships. I know it's like almost, I mean, it feels very cliche to say that. I've been in groups that have tried to accomplish that. It's hard, and it's often been, kind of mandated from above with little success. But I think that with intentional efforts to identify strategies that can bring those groups together, we can hopefully make some progress, and really it's going to be critical to move forward. And finally, knowledge exchange and expertise development. As I mentioned before, that cross-generational exchange is so important. We need to focus on training new and early career scientists that maybe don't see themselves as boundary layer tangential at all, but have the opportunity to apply those concepts and carry the science forward in their own spaces. And then also that summer school concept, I think that's a way to really kick that off soon. And it not only helps with the knowledge exchange and expertise development problems, but it can also help us with that hiring and recruitment standpoint, where we can start to identify people that are interested in this and start to build that expertise in the broader community that then we will have a pool to recruit from. So that's all I have to share now. Again, I want to give you the opportunity to download the white paper. Please take a look at it. We are open to feedback on all of it. Those focus groups are going to be happening later this week for us to gain that feedback. The open community session is planned, same place, same time, same Google Meet link as right now for next week. We're also open to you just, I don't know, sending us an email. And what we have to do is take all of that feedback, pull it together, and then start to send it to those decision makers. So the unit directors in our building, the vice president for research office, all of these places. And then when those funding opportunities come, we can pull it out and say, look, we have a plan. We are ready to move forward. And so I hope that by presenting it to you guys like this today, we can get you involved. Myself, Tyler, and Jeremy can't do this on our own. And it would be really a shame to lose the interest in boundary layer outside of our little NSSL bubble that the three of us have built. So please, we're asking you to join us, help us out, be part of it, and take ownership in this concept. And with that, I don't have anything else to say.
So Elizabeth doesn't have to moderate herself and answer questions. I'll act as moderator this time. If you do have a question or a comment for Elizabeth, you just indicate it, either the question itself or just say you have a question in the chat box, and then I'll call you out one by one so we don't have everyone talking at the same time. No questions? Okay.
I see positive feedback in the chat, so that's good. I'm glad you guys agree. On the topic of the summer school idea, one important part of that will be getting people to lean in on that from the different units in this building. We'll need experts that are beyond what, I can provide and things like that. And also, I can't plan the whole thing by myself either. So if you and your group have interest in participating in a summer school or helping us develop the idea for a summer school, please reach out and, we can start that process.
Yeah, go ahead, Liz.
I also can say that the REU program for the recompete, I'm echoing really bad, I don't know where it's coming from, but we included a summer school type experience for the REU students, focusing on interactive components like a lot of the boundary layer research in the recompete. So there may be a type of framework we may be able to use and start to pull in to the larger community as part of that too. So I can talk a little bit more about that because I helped draft a lot of that segment. So we can talk more offline about that, but I wanted to say we started a little bit of that framework already.
Yeah, during our I don't know, we've been calling them idea sessions, or actually I think we've been calling them boundary layer idea happy hours, but Tyler, Jeremy, and I have kind of started to draft a skeleton of what we think that would look like, and even some of the people that might be useful in the community. So yeah, we should definitely overlap on that.
Dr. Becerra, did you have something to say? I muted you because you were echoing.
I usually do. But what I was just going to really just reiterate that the summer school idea, I think, is a really good idea. I'm curious, though, obviously, where would some of the support, there's support in terms of bodies, but any thoughts on support, where we could go for support in the broader community to help to drive this forward? And do you have any thoughts on that?
I do have thoughts on that. I've been thinking about, I think as Bob has mentioned here, there's a lot of opportunity out there to collaborate with some of the minority serving institutions and the centers there, and there's funding associated with that we could explore. Also, I think this is an opportunity to work with the VPR's office and try to see where they think this can fit. This is something that can act as recruitment of research dollars to this university. And so that seems like an appropriate place to get those folks involved. But as far as the details about where that funding will come from, no, I do not have details there because it depends on who's involved and what topics we end up moving toward.
Still think it's a great idea, so keep going with it.
Thanks.
Dr. Tilson, you had a comment?
Yeah, I was going to listen to see if I'm echoing, but I'm not. This is obvious to some extent, but I think it plays to our strengths. And I attended the Future of Atmospheric Boundary Layer Research that was held a few years ago. And one of the key takeaways that came out of that was the joining of modeling capacity and observational capacity. Again, it sounds obvious when you see it, but if you look at the group that was assembled, that was a pretty high power group. They were indicating that you make the observations and then sometimes the modeling is added as an afterthought or vice versa. So, we have the LAS and the DNS skill and the numerical weather prediction skill. We have a lot of measurement skills. So I think getting more campaigns that we can leverage each other's strengths and not, in a very consistent and kind of knitted together way. And I know I'm preaching to the choir, but there, despite how obvious that seems, there still seems to be a need for more cohesion among the observationists and the modelers, and that definitely plays that's in our wheelhouse.
Yeah, absolutely, I agree.
Dr. Rabin?
Hi, can you hear me okay?
Yep.
Oh, great. Yeah, just a couple comments. I really applaud the work in this area because I think it's really important. And I just wanted to mention a couple things about it. I think the community here, the scientific community, has been involved in PBL studies for a long time, way predating the Weather Center. There was actually a campaign back in 1983 called BLX 83 where standing Doppler lidars were used from the University of Wisconsin with a tethered balloon and flux measurements. So it's not, it's not a new initiative in the true sense, but I see it as a growing one. I'm also excited about the maybe possibility of linking up with NCAS, the National Center for Atmospheric Science Studies, which is one of the NOAA science centers for minority students. They actually have a partnership with, I believe it's University of Maryland, Baltimore County at Beltsville, Maryland. There's a site there where they take they're working on boundary layer studies with LIDARs and celiometers and other equipment measuring fluxes. So I actually see a really good crossover there. So I think that's just something that maybe we can discuss in more detail later, how to try to link up with them.
Yeah, that would be great. We have collaborated with that group at UNBC before on some field programs. So I think that it'll be a natural kind of connection there. So yeah, that'll be good. Let's talk about that.
Dave?
Yeah, very nice presentation, Elizabeth. So as a former NWC person, I fully applaud this effort. I just wanted to say that there was the question that Jeff brought up. How could this be supported? I've been working with Tilden Myers at Air Resources Lab to try to create basically a NOAA-wide boundary layer program. And one of the shortcomings is exactly what Elizabeth has pointed out, is that there's not a lot of young talent coming into this area, perhaps. And so I really do support that sort of the growing of the the capability, and I hope that the school and the other entities there can really embrace that, because we need more people who understand these different remote sensing technologies and how to use them. I had an advertisement for a postdoc, to actually work on model, PBL parameterization schemes that went unanswered for a long time because there just wasn't enough people out there with any sort of experience in this at all. And so I do really support this, and there may be, if this cross NOAA program gets off the ground, then that would be an opportunity to support some of this also.
Yeah, that's a good point, Dave. And I should mention, now that you brought that up, that this is kind of stage one and how we see this vision evolving. And I think stage two is after we hopefully get everybody together around the campfire here at the Weather Center, is identifying those really important connections to other activities that are happening like this one. And the activity that you've referenced, trying to build this NOAA-wide kind of cohort working on these problems, that is one of those. Because I think that all of the labs from OAR that are involved in that effort can benefit from the additional expertise that's in this community as well. So I do want to make that clear that we do definitely want to collaborate with these outside groups as well.
Are there any other questions? Okay.
Okay.
I think that's it then.
Well, thank you everybody for taking the time to listen. And again, please do come to that session next week at 2 p.m. And or send us emails. My email is elizabeth.smith@noaa.gov. So, thanks. Have a good rest of your Tuesday.